Solutions. A solution is a homogeneous mixture. Now, a homogeneous mixture means that you have two or more things that are mixed together and it's uniform throughout. So there's no layers, there's nothing sitting on the bottom. That would be heterogeneous. And so anywhere you sample in a homogeneous solution, you're going to find exactly the same thing. So there are several different kinds of solutions. But before we go into the different kinds of solutions, we have two terms that you need to know. One is that you have something called the solvent. Now usually this is whatever it is it's dissolved in, but the definition we're going to use is that it's whatever there's the most of. So the solvent is whatever there is the most of. And we have another term called the solute, and it's everything else. So if I have a mixture of, say, 70% ethanol, which is regular old alcohol, and 30% methanol, which are two liquids, which one do you think is going to be the solvent? Well, if we go by the definition of what the solvent is, well, 70% is what we have the most of, and methanol is everything else. There's only two things in there, but ethanol is the solvent and methanol is the solute. And we can flip it around. And if we were to say 30% ethanol and 70% methanol, well, in this case, the methanol is now the solvent and the ethanol is the solute. And so let me mark these up here. So this is the solvent, solute. And down here, this is the solute, and this is the solvent. So I've labeled these. I've decided, which one's a solvent, which one is a solute. One thing you have to be very careful about is don't get fixated on that, particularly if water is a solvent, that water has to be the solvent. Remember, it's not that it's what it is, it's how much you have. And so if I had something like isopropanol, which is rubbing alcohol that you can buy in any grocery store or drug store, if I have isopropanol, it's 70, rubbing alcohol is 70% isopropanol. And 30% water. That's regular rubbing alcohol. This is how you buy it in the drugstore. It's 70% isopropanol and 30% water. And if you look here, the solvent is the isopropanol. It's 70%. And the solute, well, that's the 30% water that's right there. And of course, if we reverse the concentrations, it would be, if we had 70% water and 30% isopropanol, let's say we diluted it out, well, then the water would be the solvent. But in the case of rubbing alcohol, water is the solute. So whatever you have the most of is the solvent. Everything else is a solute. Now, take the air that you're breathing. The very air that you're breathing is a homogeneous mixture. It's roughly about 70% nitrogen, about 24% oxygen, a little bit of argon, a little bit of CO2, and a little bit of water vapor. And so it's a mixture of a bunch of different gases. But what's the solvent? Well, it's the 70% nitrogen that's in this room. And everything else, the oxygen, the argon, the CO2, the water vapor, everything else is the solute. So the nitrogen in this that you're breathing right now is actually the solvent. This is a gas-gas mixture that's in here. So some examples of solutions There's some that we can have. I just mentioned air. The very air you're breathing is a gas mixture. It's a mixture of nitrogen, oxygen, CO2, water vapor, and argon. Okay, that's a gas mixture. Now we can have other kinds of homogeneous solutions as well. How about if we dissolve things in liquids like water? And so if I had something like solid liquid, a good example of that would be like if you take a glass of water and stir in salt to make salt water solution. Salt, sodium chloride, is a solid. The liquid is the water, and you make a salt water solution. Salt water. Another example of a solid in a liquid solution is sweet tea. Sweet tea is a little bit of water with a lot of sugar. And so sweet tea is a solid liquid solution. Sweet tea is a good example for a lot of things that we're going to talk about with solutions. So that's a solid and a liquid. Now we can have another kind of liquid solution with water or any sort of substance, and you can have gas liquid. And can you think of a solution that's a gas dissolved in a liquid? Now, if you look at soda, that's exactly what soda is, a Coke or a Pepsi or whatever. It's actually, the fizz is actually dissolved carbon dioxide gas dissolved into the liquid water, which is what soda mostly is. So soda is CO2, carbon dioxide, dissolved in water. And we could have, say, a liquid. And we did that earlier as an example. Isopropanol alcohol. So rubbing alcohol or isopropanol, 70% isopropanol is a great example of a liquid. Isopropyl alcohol is a liquid, and as is water. So we can have solid and liquid, gas and liquid, liquid. How about solids? Did you know that solids can form solutions? Now, the way you would form a solid is you wouldn't take some solid and just mix it together with another piece of solid. Well, it won't form a solution, which is a homogeneous mixture. So what do you think you have to do to get a solid mixture? Well, you would melt them. You melt the solids until they're melted, and then they'll mix, and then you allow it to cool. And so an example of a solid solution is steel, like stainless steel, or the steel that your car is made out of, or steel that they build buildings with. And steel is mostly iron with a few other things mixed in, like for instance, mostly iron with a little bit of carbon. You got carbon steel. You got mostly iron, and you add nickel and chromium in the right amounts, and you get stainless steel and so forth. So steel, the stuff your car is made out of, is made out of a homogeneous mixture of iron with various other things added to it. It's mostly iron. Another example of a solid homogeneous solution is brass. Brass is copper that has some other metals mixed in, such as you can have copper, mostly copper, and you add zinc to it. That's a brass. A brass is not a specific copper mixture. It's anything you add into copper. It's by definition of brass. So we have steel and brass as examples of solid mixtures or solid homogeneous solutions.